So if you take a look at this problem here, and you'll notice about this problem to start off with compared to what we just saw a moment ago. 2 plus the square root of 5 is 2 objects. Something plus or minus something else is a binomial structure. When a binomial contains a radical, that's a little bit more challenging to get rid of. And we're going to use the difference 2 squares idea to do that. So the difference 2 squares, if you recall back from earlier this year, back in Algebra 1 also, a little bit in geometry. If you multiply a sum and difference of the same 2 objects, and you do FOIL, first times first is a squared. Your outer objects, negative AB, and inner objects, positive AB, are going to cancel. So that's the whole idea. We're exploiting the part of the canceling to get rid of the radicals here. And then we do last times last, we're going to get our negative b squared. When you square a square root, the square root disappears. So for example, if I did the square root of 17 squared, that equals 17. If I do 2 times the square root of 3 squared, that equals 12. Take a moment to digest that one there. What is 2 times 2?
4.
And the square root of 3 times itself equals 3. So 4 times 3 makes you 12. Okay, so if your square root happens to be simplified in some way, shape, or form, when you square it, you're squaring both pieces of it. So square this, and then multiply the results. Right? But the idea is that we're going to have square roots in our object. Our square root is going to be one of these binomials. So when we do our FOIL technique, we're going to get the first thing squared minus the second thing squared. So when I see this structure in a problem, 1 over a binomial radical, and it doesn't matter if you got 1 or 2 radicals. If they're both radical, it doesn't matter. If there's 1 radical, if there's any radicals on the bottom at all, this will work. Okay, but again, 2 objects requires us to do this technique. And the technique is as follows. We're going to multiply by exactly the same thing as this here, except I'm going to change the sign in the middle. So this is what we have, matching, except plus is minus. For a vocabulary word, that's called the conjugate. That's what that's called. We multiply by the conjugate. And again, whatever sign this is, just make it the opposite. If this said minus, this would say plus. This says plus, so this says minus. And if I multiply the bottom times something, I've got to multiply the top times the same thing. Like so. And still fraction rules are happening here. So we have to abide by the fraction rules, modify the bottom, modify the top the same. On top, I have a monomial, 1, being multiplied by a binomial, 2 minus the square root of 5. So that's just a distributive property scenario. So on top, I'm going to get 1 times 2 is 2. 1 times negative the square root of 5 is negative 1 times the square root of 5, or just square root of 5. On the bottom, I have this difference of squares structure. Again, this is the same structure as that. And what the difference of square structure says is what I should get out of this is the first number squared minus the second number squared. You can feel free to do FOIL if you want to, but the outside and inside products are opposites. Negative 2 square root of 5, positive 2 square root of 5, they cancel. So instead of doing FOIL, the O and the I cancel, you can do FLO on that if you want to. FLO. FL. Positive times positive makes positive, positive times negative makes negative, and you're just getting them squared. What's left to do now is to simplify. Top cannot be simplified. Don't leave the square root off. 2 minus the square root of 5. On the bottom, 2 squared equals 4. And the square root of 5 squared equals 5. And they're being subtracted. So 4 minus 5 is negative 1. And that's a perfectly fine final answer. For me personally, if I got over negative 1, if I just change the signs on the top and make it a non-fraction, that's prettier. But if you get to this point here, I'd be satisfied you know what you're doing. But again, divided by -1, change the sign, change the sign, change the sign. It's over +1 now, and that just means whole number structure, right? So the bottom is no longer a radical, that's our goal. I don't care what the top is. The top can be radicals, the bottom can't. Just real quick, just to verify this, for some people like to see things verified. Let me show you something here. Let me take my calculator all the way over here so we can see. Shoot. All right. So we're creating an equivalent expression. In other words, that the thing they gave me to start off with, this thing should be equivalent to this thing. They should be exactly the same. All right? I can't show you the exact value because it's irrational. It goes on forever and ever and ever. But I can show you that the decimal approximations are the same. So if I type in this thing, 1 divided by parentheses, 2 plus the square root of 5. My calculator, every time I type the square root, it automatically puts parentheses. I'm going to end parentheses, finish that, and end parentheses, finish the bottom. I need that bottom in parentheses, so it's 1 divided by that whole sum, not just part of it. All right? That's what the original expression equaled. My answer, let's go with this answer here, -2 plus the square root of 5 is exactly the same number. This binomial over -1, if I put parentheses, 2 minus the square root of 5, end parentheses, finish the square root, a second end parentheses, finish the top, divided by -1, exactly the same thing. Again, they're all equivalent, but this has no radicals on the bottom. This does, so this is better. All right, so that's our idea here. Binomial on the bottom, multiply by the conjugate, fix the top, fix the bottom, circle your answer.